Students, in this lecture, we'll discuss about the block diagram algebra of module 2. Okay, so whatever is the input output behavior of a linear system or element of a linear system is given by its transfer function g of s is equal to c of s by r of s, where r of s is Laplace transformation of the input variable and c of s is Laplace transform of the output variable. Then we'll see what is block diagram. It is a convenient graphical representation of this behavior. The signal into the block represents the input R of S and the signal out of the block represents output C of S, while the block itself stands for the transfer function G of S. Then the flow of information, that is signal, is unidirectional from input to output, with output being equal to the input multiplied by the transfer function of the block. If there is a system and that system is complex, which it is compromising of several non-loading elements, then it is represented by the interconnection of the blocks for individual elements. The blocks are connected by lines with arrows indicating the unidirectional flow of information from the output of one block to the input of the other block. So, apart from this, uh, in addition to this, summing or differencing of signals will be indicated by the symbols which has been shown in figure B. You can see the block diagram has been shown in figure A. The summing or differencing of signals is shown by symbols B, while takeoff point is shown by C figure, which represents the takeoff of a signal. Then the block diagram of the sum of the control system turn out to be very complex, such that their evaluation of the performance requires either reduction or simplification of block diagrams, which is carried out by block diagram rearrangement. So we are now going to discuss the block diagram of a closed loop system. Okay, closed loop system. Closed loop system. So this diagram represents the block diagram of a closed loop system. The upper block is with G of S. The feedback block is with H of S. Then there is a summing point. The two signals to summing point are R of S and B of S. Then E of S is output of summing point given as input to G of S. C of S is output. There is a takeoff point. Okay, that we are going to study. Then this diagram represents the block diagram of a negative feedback system. Negative feedback system. So whatever terminologies that are used in this block diagram of control system, okay, should be R of S represents reference input, B of S represents feedback signal, E of S represents actuating signal, G of S represents C by S, C of S by E of S, which represents forward path transfer function. So H of S represents transfer function of the feedback elements. G of S, H of S is equal to B of S by E of S, which is loop transfer function. T of S is equal to C of S by R of S, which is closed loop transfer function. Then from figure A, if you refer it, we can write C of S is equal to G of S by E of S. So E of S is equal to R of S minus B of S, which we can write it as R of S minus H of S C of S. Okay, then taking the above two equations, eliminating E of S from the above two equations, we have C of S equal to G of S R of S minus G of S H of S C of S, or we can write C of S by R of S is equal to T of S, which is equal to G of S divided by 1 plus G of S H of S. Okay, so we can see the system can be reduced to a single block which has been shown here. The system, whatever is shown in figure A, it can be reduced to a single block which has been shown in figure B. Okay. Next we'll go for block diagram reduction. Block diagram reduction. So a complex block diagram configuration can be simplified by certain rearrangements of block diagram using the rules of block diagram algebra. So now we are going to study some of the important rules which have been listed in this table. These rules have been derived by simple algebraic manipulations of the equations representing the blocks. Okay, is it clear? No. So we'll see the rules of block diagram algebra. The first rule is combining blocks in cascade. So if there are blocks in cascade, we can combine as this is the original diagram. There are two blocks in series or cascade. So we can combine these two blocks as only one blocks. Input is x1, output is x1, g1, g2, and inside the block we can have g2, g2. So when two blocks are in cascade, the gains of those two blocks can be multiplied and represented by single block. Okay, you can see here G1 one block, you can see here G2 one block. These two blocks are in series multiplied by and shown in one block G1, G2. The second rule is moving a summing point after a block. Moving a summing point after a block. You can see there is a summing point. We can move that summing point after a block. So you can see this next figure, the summing point has been moved to after a block. So summing point signals are x1, x2. Then output of summing point is x1 plus or minus x2. G is again then G into x1 plus or minus x2. So what we get is, so this summing point will be moved here. So this is G, this summing point will get shifted here. So x1 G, but we want the output G x1 plus or minus x2 means we have to add a block in series to the summing point, and that block gain is equal to the transfer function of the block which we are going to shift. So whatever is this block G, that will come here G, and this is x2. Got it? So we have to add a block in series with x2 and given as input to the summing point. Now this will become G x1 plus or minus x2. The next rule third is moving a summing point ahead of a block. So this is a summing point here. This summing point has to be moved ahead of a block. So this is x1 G, x1 G, x2. So this will be x1 G plus or minus x2. So this is x1. Summing point ahead of a block means it will come here. This is 1 by G and G. So when we shift this summing point ahead of a block, it comes here. Then it comes here. We have to add a block. In series with x2, and the gain of that block is the reciprocal of the block which we are going to use in series path. Okay, so it is 1 by G. Is it clear? Next, fourth is moving a takeoff point after a block. Moving a takeoff point after a block. So here is a takeoff point. You can see this is a takeoff point. This takeoff point must be moved after a block. After a block means it will come here. So that takeoff point will come here. So when we move the takeoff point here, then add the takeoff point, we have to add a block, and the block will be having a value or transfer function of that reciprocal of the block where it has been used after shifting. So this will become 1 by G in series with the takeoff point with X1. Okay. Next, moving a takeoff point ahead of a block. So this takeoff point here, it has to be moved ahead of a block means here. So this takeoff point has to be moved ahead of a block here means X1. This block will be in series. Then the value of that block equal to G, which is equal to the value of the block in series with the transfer function. So this is X1G, this is also X1G. So this block will be in series to this takeoff point where the takeoff point is shifted or ahead of a block X1G. Next is eliminating feedback loop. Eliminating feedback loop. So this is a feedback loop. We can eliminate that feedback loop. So it will come reduced to this form. So we can write it in a block G divided by 1 minus or plus GH. If it is plus or minus here, then here we have to write minus or plus. So eliminating a feedback is G divided by 1 minus or plus GH. Okay. So I request everybody to understand these rules thoroughly. In next lecture, I'll take 2 more rules and I'll continue with the problem. Okay. So you understand this thoroughly.